Good morning, everybody. We are looking at our last set of notes before our test. Right now, the current plan for the exam will be to probably release it tomorrow, being Thursday, and have it due at midnight on Sunday. That'll 4 days to work on it, which should be more than enough. But we'll talk about that more today when we meet for our Zoom class. What we're looking at today are inferences for two population proportions. And what this is it builds upon what we've done previously with just population proportions, where we've taken a sample and we found a percentage of the sample that has a specified attribute. Well, in this instance, what we're looking at now is comparing two populations who share an attribute. An easiest example to come up with would be if we're comparing men and women. We're going to see that in our example that we're building upon throughout the course of this set of notes. But that's basically what it boils down to. You're looking at two different populations that share an attribute, and you want to make a determination about either one or both of the populations based off the information provided in the sampling method. So for example one we're talking about, and this example one we actually build upon, like I said, we're going to build up on it throughout the duration of these notes. So this example you will become very familiar with. A survey of 1,181 U.S. adults was designed to gauge the demand for vegetarian meals in restaurants. The study was commissioned by the Vegetarian Resource Group and published it in the Vegetarian Journal. And they polled independent random samples of 747 men and 434 women. Of those sampled, 276 men and 195 women said that they sometimes order a dish without meat, fish, or fowl when they eat out. Suppose that we want to use the data to decide whether in the U.S. the percentage of men who sometimes order a dish without meat, fish, or fowl is smaller than the percentage of women who sometimes order a dish without meat, fish, or fowl. So the first thing for part A just says formulate the problem statistically by posing it as a hypothesis test. So the attribute that we're looking at here is that they sometimes order a dish without meat, fish, or fowl. And we can also say sometimes orders vegetarian. So the two populations that we're going to be looking at, we have the population 1 is U.S. men, and our second population will be U.S. women. And now we have to denote the population proportions. So here we're going to have little p is the proportion of U.S. men who order vegetarian. And then little p sub 2 is going to be the proportion of U.S. women who order vegetarian. And for our hypothesis test, the one thing we want to note, I'm going to go back up to the example here. It's the percentage of men who sometimes order a dish without meat, fish, or fowl is smaller than the percentage of women. So there's our alternative hypothesis, our alternate hypothesis for this test. So our initial hypothesis test, our null hypothesis, is going to be that the two proportions are equal. Our alternative hypothesis, P sub 1 represents the U.S. men, so it's P sub 1 is less than P sub 2. And that's all we had to establish for this one. Just formulate the hypothesis test based off the information that we're given. For part B, it just says to explain the basic idea for carrying out the hypothesis test. So what we're going to do, I'm just going to explain this. It will appear on your notes on the website, though, typed out for you. We're going to compute the proportion of the men sampled who sometimes order vegetarian. And so what that means is we need to compute P sub 1, or it's P hat, sub 1. Remember, that's the sample proportion. And that would be the proportion of men who order the vegetarian meal from the sample that we had. Let's see, 276 men that said they ordered vegetarian out of 747 sampled. And then P hat sub 2 is the proportion for the sample of women, which would be 195 out of 434. Then we would look at the comparison between P hat sub 1 and P hat sub 2. And if P hat sub 1 is too much smaller than P hat sub 2, we would reject the null hypothesis. Otherwise, we would not reject the null hypothesis. And again, when we're just establishing kind of a basis here. We're not talking about hypothesis testing just yet. So when we say that P hat sub 1 is too much smaller than P hat sub 2, that is, relatively speaking, based upon the relative z-scores that we come up with. We have to come up with that margin of error and that tolerance level before we can decide what actually quantifies the phrase too much smaller. Then for part C, it says discuss the use of the data to make a decision concerning the hypothesis test. So I already established the proportion equations in the first part. So we're going to simplify those now. Here we have P hat sub 1 is going to be 276 over 747. And that's going to be approximately equal to 0.369. So about 36.9% of men in the sample group ordered vegetarian meals. And then P hat sub 2 will be the sample proportion for the women, which was 192, 434. That's going to be approximately equal to 0.449. So about 44.9% of women ordered the vegetarian meals. And then in the second step, what we have to do is we have to decide whether the proportion for the men is less than the sample portion of the women by a sufficient amount. Okay, that's where the quantification comes in for the hypothesis test to determine whether or not we should reject the null hypothesis in favor of the alternative. And to make that decision, we're going to have to know the distribution of the difference between the two sample proportions. And so we're going to see a couple of charts here from before we start doing any more examples. And we're going to come up with the methodology that we want to use to complete a two-sample proportion hypothesis test. So here's the notation that we need. We have the two populations. Population proportion for population 1 is P sub 1, and then for 2 it's P sub 2. Sample sizes, we still use the same variables, but now we just do a sub 1 and sub 2 to indicate which population it represents. The number of successes, that's the number of people in the sample that have the specified attribute. Like in the previous example, we were talking about people who order vegetarian meals. And then the sample proportion is the number of people in the sample who have the attribute divided by the number of people sampled from that specific population. The sampling distribution between two sample proportions. This just goes through to illustrate how we know that the sample proportions are going to be normally distributed as long as we have what we would consider to be a relatively large sample size. So here's where we develop our hypothesis testing procedure. What you see here is how we compute the value for Z, which we will use to do our comparison. We can go through all the steps prior to this, but essentially when it gets down to it, this is the final step for Z. It's P hat sub 1 minus P hat sub 2 over the square root of P minus 1 or times 1 minus P times the square root of 1 over N sub 1 plus 1 over N sub 2. And that will become our test statistic. But as we've seen previously, we don't always know what P is. So we will use a proportion or a sample, the sample proportion for P. And that is found by taking x sub 1 plus x sub 2. So that's the number of people in each sample who have the specified attribute divided by the sum of the sample sizes. And so that gives us our new equation for Z, where we replace the P's with the P hat sub P. And here is the steps in doing the proportion Z test for two samples. So we assume they are simple random samples. We assume they are independent. Here we have x sub 1, n sub 1 minus x sub 1, and n sub 2 minus x sub 2 are all greater than 5. And I should have also included x sub 2 in that list. So x sub 2 should also be greater than 5. The null hypothesis is that the two proportions are equal to one another, so that will always be the same. And then your alternative hypotheses are going to be the same things we've seen before. Either the two proportions are not equal to each other, which is a two-tailed test. Proportion 1 is less than proportion 2, so it's a left-tailed test. And then proportion 1 is greater than proportion 2, giving us a right-tailed test. We decide on the significance level. We compute the value for Z. And then we can do either one of the two approaches, the critical value approach or the p-value approach. And this goes back to using the Z table. So let's look back at that previous example. And here we're going to set up a 5% level of significance for our test. So we want to determine, do the data provide sufficient evidence to conclude that the percentage of U.S. men who sometimes order vegetarian is smaller than the percentage of women who sometimes order vegetarian. Use a 5% significance level. First step, state the null and alternative hypotheses. The null hypothesis is going to be the same in every case. That the two that the two proportions are equal to one another. The alternative hypothesis for this one is going to be that the proportion of men is less than the proportion of women. So we note here that this is left-tailed. Our significance level is 5%, so we know then that alpha is 0.05. And now we can compute our test statistic. We've already found, we know that we know that x sub 1, that's the number of men who eat vegetarian, is 276. The sample size for the men is 747. The number of women who eat vegetarian is 195. The sample size for the women was 434. In the example 1, we've already computed the values for p hat sub 1 to be 0.369. And p hat sub 2 for the women is 0.449. The only other value that we need to compute before we can find Z is the value for p hat sub p. And remember, that just simply takes the sum of x sub 1 plus x sub 2 over the sum of n sub 1 plus n sub 2. So in our case, we have 276 plus 195 over 747, 434, and that's going to be equal to 471 over 1181, which is going to be approximately 39.9, well, I didn't mean to put two decimals in there, 39.9% of our total sample favors vegetarian meals over non-vegetarian meals. So now we can actually come up with the value for Z. And so Z is equal to p hat sub 1 minus p hat sub 2 P n sub 1 plus 1, 2. And when we substitute in our values that we have 0.369 minus 0.449 over the square root 0.399 and when we simplify this, we get a z-score of negative 2.71. So here we are do our two different approaches. We have the critical value approach and we have the p-value approach. So for the critical value approach, we have a interval of 0.05, or a confidence level rather, significance level is 0.05, and we know that corresponds to a z-score of 1.645. But since this is a left-tailed test, we will make that a negative 1.645, because remember, the z sub alpha gives you the area to the right. We are looking for the area to the left in this case. So when we're talking about a left-tailed and a right-tailed test, we just simply negate the value that we come up with for the right-tailed test. And so we will take our normal curve. If we just imagine what it would look like here, we're looking at negative 1.645. Left-tailed test includes everything to the left of that region. And our z-score of negative 2.71 does fall in that rejection region. So we would reject the null hypothesis, which made the claim that the two proportions are equal, in favor of the alternative hypothesis, which suggests that the proportion of men who favor vegetarian meals is less than that of women. So our critical value test does say to reject the null hypothesis. The p-value approach, the area that corresponds to negative 2.71 when we look on the z table, for negative 2.71, going to be right here. It's 0.00336. So there's our area. We want to compare that area to our significance level of 0.05. It is clearly less than 0.05. So the p-value approach says that when our area is less than our significance level, we reject the null hypothesis. And so what this means in terms of an interpretation is that at the 5% significance level, the data provides sufficient evidence to conclude that in the United States, the percentage of men who sometimes order vegetarian is smaller than the percentage of women who sometimes order vegetarian meals. And when we want to look at the, again, when we're looking at confidence intervals, we've done this for single samples. We can do a confidence interval for a large sample. The assumptions are still going to be the same. It's step 2 that we want to focus on. Our endpoints of the confidence interval can be expressed by taking the difference between the two proportions, plus or minus the z sub alpha over 2, which is the confidence level. Alpha represents the confidence level. And then we have that big long square root of p hat sub 1 times 1 minus p hat sub 1 divided by the associated sample size, plus p hat sub 2 times 1 minus p hat sub 2 divided by its associated sample size. So putting it in an example would probably be much easier to understand. So with example 3, we're still looking back at example 2, which refers back to example 1, and we're finding a 90% confidence interval for the difference between p sub 1 and p sub 2. And we will first set that up as if we have a 90% confidence interval, that corresponds to an alpha of 0.10. It's just 1 minus 0.9, and we get 0.10. And then we need to find our value for z sub alpha over 2, which now goes to z sub 0.1 over 2 sub 0.05. And we know that already to be 1.645. So the endpoints are found by taking p hat sub 1 minus p hat sub 2 plus or minus z sub alpha over 2 times the square root p hat sub 1 and we're just going to substitute in our values. We have p hat sub 1 is 0.369 minus 0.449. We just computed our value for z hat sub 2 to be 1.645 times the square root, substitute in all of our values again, 0.369 minus 0.369 over 747. I'm running out of room. 434. When we type this all in, we do these values with the plus, then we do the same values with the minus. What we're going to end up with is negative 0.80 plus or minus 0.049, or we can write it out with the two distinct values as negative 0.129 to negative 0.031. So there is our confidence interval for the two populations. And when we interpret that, what we're saying is that we can be 90% confident, that was our confidence interval, that in the United States, the difference between the proportion of men and women who sometimes order vegetarian meals is somewhere between negative 0.129 and negative 0.031. In other words, we can be 90% confident that the percentage of U.S. men who sometimes order vegetarian is less than the percentage of women who sometimes order vegetarian, somewhere between 3.1 and 12.9 percentage points. If those values had been positive, then it would have been greater than. In this case, we are talking about it's smaller than. So the difference is going to be somewhere between 3.1 and 12.9 percentage points when we compare the men to the women. There are your homework problems. Like I said, we will discuss the test a little bit further this afternoon when we meet at 2 o'clock. And just hope everybody's doing really well. And I look forward to seeing you guys at 2.